So the next speaker is Sergii. We're in the same team, so I know him very well. And he's going to talk about how to build a data streaming service and not get killed. And the reason we're both alive is him and him only. So there you go.
Hello. So let me introduce myself. I'm Sergei. I'm working in data services. So I'm front-end developer. That's the rare beast in our department. And so I want to talk about self-services. So why it's a bit different from just service, and what it means, and how to build it, and how to build it well, how to run it on a large scale, because Zalando, it's. So as you know, we grow very fast, and we have a lot of people. We have a lot of different stuff to manage. So where we are right now. So we have just about 380 teams. It means like a lot of people. We have 5,000 active applications, which microservices, can you imagine? And we have 500 engineers, which is produce a lot of problems for us. And our team is building streaming service, and it means that we are talking about a lot of data. This is central bus of Zalando, so there is a lot of data, terabytes, and a lot of different data types and topics. So, and we only have 7 engineers. So how we can handle it? So let's back 3 years later. So back to the requirements. So why we need central bus for Zalando? So we want to send asynchronous data and a large data streams from one application to another, and from all applications to data lake. So requirements was REST API, because it's standard in Zalando, with, of course, JSON payload. We need to ensure data quality, because we rely on the data quality. So we need stable schema changes. So if someone wants to introduce new field, he should not break the consumers and BI and all the departments that he don't know about. So then, because we have like a lot of teams, we don't want to allow different teams to be nasty to each other. And another requirements, of course, high availability and high scalability, and it is even more than AWS can provide. So that was one of the biggest requirements. And because it's the whole Zalando rely on it, we cannot allow it to die like suddenly, even for several minutes. So it should be future-proof without vendor lock, and it was a challenge, and it should be easy to operate. So that's what I'm talking about right now. So, and of course not expensive, but it depends. So we built it. So we built Nakadi, which is open source project. Everyone can check it out. And what it does, it's actually a very, very smart proxy. So as you can see, on the backend, we have Kafka cluster. But you can see that there are several Kafka clusters, because this proxy allows us to switch traffic without breaking consumers or publisher without, so we can switch from one region to another, we can switch from small cluster to bigger cluster, we can switch from clusters that optimize for low latency and cluster for optimize for bigger payloads. So there are a lot of stuff that allows us to do. Plus it checks the data quality. It has internally schema register. It checks that the schema doesn't break. So a lot of stuff. So we build it. Now what? So first of all, of course, documentation. No one reads it, you know it. But there is a but. So if you just start from examples, if you the first thing user sees example, it's enough. He can start understand it. Like we are developers, we love code, so it's like examples is the first thing you need to see, and then it should be only one source of truth for your API. I saw many times when the API definition and the code was not in sync, outdated, and it's both not in sync with external documentation. So to prevent this mess, everything should be documentation and API, and your code should be together. So then we found out that for bigger project, for if you have an open source project, you have open source documentation, but also you have to have your own internal documentation, and they should be linked, and people should understand. So this is the product, and this is how you use it. It's totally different thing. It can be, especially if you have some plugins, it's completely different. So keep it in mind, separate it always. And collect frequently asked questions from the very beginning. Like this is things that bother us a lot, because people tend to ask the same questions many times. And if your service grow, these questions will appear again. So collect each question. It will appear again at some point. So this helps us a lot. So we had special, so we have special role in our team that we call it Penguin. The guy who is answering the emails and in chat and everything. And also what he does is writing down these questions to a special file that we then convert to frequently asked question documentation. Why? Because precise links. So if you can answer the question just with the link, it will save you like, I don't know, like half an hour sometimes. So that's why we built our own documentation engine, which is just a Google Pages template, but it's a bit smarter than usual templates, because it produces documentation from the YAML definition, and you can point directly to smallest detail of it. So to every parameter, to any fields. So whenever people ask for something, you just give it a link, say that's what you need. So, and it saves like tons of time. So how we communicate? First of all, you have to start with some demo and presentation, because it's best to be recorded, because you have to do it a lot. So yeah, almost for each team you should go and ask, like start all over again. So recorded demos is a good thing to learn. No one wants to read documentation again. So, but people like to see the video at least. So our main communication channel, user chats and emails, and because we have precise link, as I said, and because we have frequently asked question, it's very too easy to answer the question because you see example, just, yeah, please read this. So this a good thing. Then we have, of course, we have some product people, and they can go to interviewing people, and but sometimes it is easier to send a real engineer to a real engineers. They decide better what they will build maybe, and sometimes it results in a more optimal solutions. So workshops, as I said, sometimes people has different requirements and they don't want to use your service because they think it's not suitable. But if you show exactly their requirements, how you fulfill their requirements, it is much better. And of course, you have to openly talk about it on conferences. So what I'm doing. So communication turns out to be more and more present when your team grows, because it's not only taking your time, it most importantly it's taking your energy, and especially when people ask stupid questions, and especially if you are doing the same stuff. So especially if this automatic job and user actually can do it, so why you should do it? So we decided we need UI maybe, but why? So first of all, again, documentation. So documentation important when you're in the context of something. You don't read documentation from beginning to end. You read only things you really care. So this UI is, first of all, what it should do is provide the links to some parts and some answers very precisely in context. So I have some statistics, so people use it a lot, like I know it. So then, so as I said, we have almost 3,000 event types or topics, and how you find the things you need, especially if it's not your but some other guy, or so you need to provide a way how to search through topics. So we have the UI that search everywhere, everything, so you can find there all your subscriptions, all your topics, all your applications, everything, and very quickly. And even our engineers use it a lot, because whatever someone asks, I have a problem with this, just go there, one click, and you see what is the problem actually. So CRUD operations. So user now can create, delete, update their stuff without asking you, which is a lot. If you have just API, every time people asking how can I create this, how can I delete this. So this saves a team a ton of time, and also it provides a way of communication. So users start communicating to each other using links. So links, direct links to some entities, very important. So we paid a lot of attention to build the links so they can be readable, and then point to exact event type, to exact event in this exact partition. So you very clearly can communicate, I have the problem here, and send the link. And also delete can prevent you from stupid mistake. If you use just API and you just delete thing without any confirmation, it can happen sometimes. So UI show you what you are deleting and ask you confirmation, ask you to check the things that rely on this event type, for example. Then that's like most important part for event bus. You can actually publish things by hand. So if you debug something, you can produce some events. You can see how it look like inside, because our bus actually changes a bit events. It injects metadata in it, like when it was published and how and some other stuff. So you can publish it from UI, you can read it, and there is a small download button. You can download samples of this data, and you can try locally stuff that you're interested in. And another interesting part of it, so because this streaming doesn't, so you have to understand where you are in the stream. So this navigation make it easier, like, you know, I'm reading this part of the stream, so it's nice to have. So next, now we have all this thing, people using it, and we need to monitor it. Okay, we need to monitor it, but user also need to monitor it. And what we do, so we have our own monitoring. We use Zmon, also open source system, very nice system. It has checks, it has alerts, so you can see all this, what's going on here. But also it has a nice feature, and it allows us to build parameterized dashboards. And we, for each entity, for datasets, for subscription, we have separate board. So everyone can use it, and everyone can analyze how they publish, or if there is a problem, you can add alert to this graph, and it allows you to monitor things out of the box. So we, like, our users spent a lot of time set up this monitoring before, and when we implement it, everyone just use it out of the box. And it's also important because when something happens, it's already too late to do monitoring. So we monitor everything from the beginning, no matter is it like user care about or not. We just write everything. And from this monitoring, the next step was building trust, how you build the trust. So even internally, we run our services. We think about our service as a service for the internet. So we have the same thing as all services has, AWS and all these self-services. We have service indicator, service agreement, and service objective. And we monitor it ourselves, and we send, like every week, we send weekly report to stakeholders. So it allows us to build the trust, and people see that service is working and it can be trusted. And we have, like, people say that our service is more reliable than AWS on which one run. So, and from this point, the next step is the KPIs that we collecting. So also we have, like, we eat our own food. So we send our KPI data through our service to Nakadi. It goes to data lake, and we build KPI graphs that used by our analytics and by our product people, and it use it for decision about investment. We track adoption of new feature in our service, and it's very useful tool, and can recommend it. So how we enforce best practices? So first of all, we need to decide what the best practices. So we have API guideline for it's actually API. So it has two parts. One part is the REST API for all microservices in Zalando, and we have special part for event producers, because when you produce event, it's also an API. You have to think about it as an API. You have to treat it as an API. You should not create breaking change and all other things that related to API also related to event. So, for example, we implemented a very nice new feature, security. So each event type has its own access tables. So you can ask Nakadi not to allow anyone to access your data, only some people. But we cannot force people to use it immediately, because it breaks the whole Zalando. So we don't want it. What should we do? We should go slowly. So one by one, somehow. Another feature that we some times ago implemented was schema evolution. It allows you, so we have a schema of event. If someone tries to publish something not conform to schema, we reject it. And if you want to add something, add some field to the schema, we also check that it does not break existing consumer. It's very nice feature. It saves from a lot of mistakes, but not everybody using it. We see a lot of first thing, like additional property true, so you can send wherever you want. And it works somehow, but it doesn't look right. So what we do? Gamification, of course. So we introduce some checks. So every time you open dataset, it's topic. Every time you open the topic, it produces some checks. So we check security, we check how schema used, we check all other types, and we nominate some badges, and everyone in the company can see it. So you'll be embarrassed if it's your data type and it's not good, but you will be proud that your data type is green. And we found, using KPIs that we have, that it works. So people actually use it, and they start to use new features because they want to be good. That's all. Everyone agree with it. So gamification, right? But what to do if it's not happening? So we have compliance report that uses the same API and produces some results. And you can chase people directly and ask them why you not follow the best practices, and so convince them or do something with it. So that's we do regularly, and we see adoption is growing, so we have new features, and it's good. So in the end, we end up in UI that combines all this knowledge that I just shared with you. So this is Nakadi UI. You can see, so you can inspect streams. You can see events inside the stream. You can search through it. You can find all data types and all subscription, like here. And you can find a lot of useful information. This is how search works. And you can see all the producers and consumers of your data and some more stuff. So that's the good part. So even more interesting, it's open source. Nakadi is open source. UI is open source. Zmon is open source. So you can build the same thing we do in your infrastructure, and you will have all this knowledge that we are now have in painful process. You can have it for free. But I ask you, if you use it, please contribute back. It helps to grow community. And one of the interesting things in Nakadi UI is that it builds in Elm. Who knows Elm? Yeah, it's very new. So it's maybe one of the largest project open sourced is on Elm. Very good functional language, and it's best for learning and how to functional language works. And like I'm really love to see more people using it. So you can contribute. There are open issues, very easy to start with it. So please go and check it out. And that's it. So
thank you. Do we have any questions? Yes. No.
Hey, how did you prove high availability for you? Did you use some kind of chaos monkey or some manual disaster test?
yeah, so periodically we run some manual house monkey. We are just killing randomly stuff, and we prove it that it works because there was some incident on AWS, and we survived it, and so it works. We know it, and we also, because as I said, this is a proxy. Even if something die, we just switch traffic. It's so easy. Just we don't actually transfer data. So if it dies there. The data is backed up anyway. We have several ways how to back it up. So we prove that it works.
Any other question? Yes.
So, how agnostic is that? So, how hard it would be if you want to change AWS for something else?
There is nothing about AWS in our service, so we run it on Dockers. So everything is Docker. UI is Docker. So you can actually go to this project. There is a Docker Compose there. You just can run it on your machine. Everything. Nakadi, Kafka, Zookeepers, UI, everything. So we can run it everywhere.
So if we do CRUD operation on a proxy, so how would you notify the consumer about the changes? It's quite not familiar. I'm quite not understanding, like, why would we need to change the schema or the events that going through a proxy or a brokerage, or and then once the schema changed, or even the event being killed, how would you notify the consumer of the consumer waiting for the data?
So that's the point of Nakadi having schema register inside. So when I'm producing data, we check the current schema. When I want to change the schema, Nakadi checks that fields that you are changing does not break consumer anyhow. So it's always backward compatible change. So you can add fields, you cannot remove fields. You can extend something, but you cannot change type, for example. So this allows us to control the data flowing in and the change of this data. So we know that it will never break our consumers, because all changes always compatible, always forward, not backward. So yeah, that's called schema evolution. So you can evolve the schema.
And I think we have one more question.
So is it the schema evolution, is it based on Avro schema?
No, as I said, everything is JSON, and the schema also JSON. So we use JSON schema for validation. Yeah.
Okay. More questions? No, I think that's it. So let's thank Sergii once again for a very interesting talk.